Okay, hello everyone in a new video. In this one, we're going to explain part 1 of chapter 1, which is the chapter of electrostatics in the first unit of electricity for grade 10 students. Then let me start by writing the title of the chapter. So, chapter 1. So, the title of this chapter is electrostatic, and the first part of this title refers to electricity. And the other part, which is static, static means not moving, which is stationary. Now, throughout this chapter, we're gonna explain what is meant by electrostatic. Now, first, as usual, let's define what is meant by electrostatic or what does it refer to. Then, section number 1, electrostatics. Now, physics as a subject can be classified into branches, and at least at this level we have three branches: mechanics, electricity, and optics, say for example. Now, also electricity itself can be divided into sub-branches, and one of the branches of electricity is electrostatics. Then let me write down that electrostatics is a branch of electricity that deals with the stationary electric charges. And now stationary refer to statics. And the first part of this title refers to electricity. Now, as I mentioned previously throughout this chapter, we're gonna understand more what is meant by electrostatic. Now, let me discuss in section number 2 an important property of matter which is given by the electric charge. Then section 2.1, and let me say that the electric charge and this quantity is denoted by small q throughout this chapter, is a property of matter and the SI unit of the electric charge is coulombs, and its symbol is capital C. Now, idea number 2.2 or section 2.2, let me say that the small entity or the elementary charge denoted by E has a value of E equals to 1.6 times 10 to the power minus 19 coulombs. As you can see that I have represented this charge in coulombs. Now, although I have mentioned that any electric charge will be denoted by Q, but since this is a special value for the electric charge, which is the smallest possible charge, and this is given by the elementary charge, and it's denoted by E. So you can also ask yourself, what is the smallest possible thing of this quantity? Sometimes we have an answer and sometimes no. In this case, the smallest possible charge is given by E, which is 1.6 times 10 to the power minus 19 coulombs. And let me add here that in 2.3, electric charge is an additive quantity. Now, quantities in physics can be classified into additive quantities and non-additive quantities. For example, we can talk about the total mass and the total volume. So we can add the masses, but we cannot add the densities. So it's always good to distinguish whether the quantity is additive or no. And let me also say that, any given charge Q so let Q be the charge of any material, can be written as a multiple of the elementary charge so here I'm saying that Q can be written as a multiple of the elementary charge. So in other words, this can be formulated as the following: Q is equal to N multiplied by E. Then this is the first equation that we're gonna visit in this chapter. Now we know that Q is the charge of the material that we're discussing and E is the elementary charge. And in this case, where N is an integer number. Now, this equation has two other forms. For example, if we are flirting N, then N can be written as Q divided by E, and so no need to flirt E because E is always given. Now here I have mentioned that N is an integer number, but this doesn't mean that N should be small like 1, 2, 3, or 4. It may happen, but it may happen that N is a very large number, but the important thing is that N is an integer number. And now let me discuss the atom model, which is described in this document. Now we know that the atom, it's not the smallest entity, but in fact it consists of other particles, mainly the electron, the proton, and the neutron. So whenever we say these are the particles, it means that this is the smallest possible thing. Whether this is correct or no, but usually whenever we say it's a particle, then this is the smallest possible thing. Then let me write section number 3, the atom model. Now, in the atom model, we're gonna make some assumptions that are true, and they are given by matter around us is made up of atoms. The atom itself is made up of electrons, let me say electrons, protons, and the neutrons. These particles are distributed as, so it consists of electrons, protons, and neutrons, and they are distributed as the following. Then let me say number one, that the electronic cloud that or consisting of electrons, and idea number two, that the nucleus containing protons now. So this is basically the nucleus containing protons and neutrons, and this is the electronic cloud, and basically by that we can say it as the electronic cloud is negatively charged. So why it's negatively charged? Because it only consists of the electrons, and the nucleus is positively charged. Now why it's positively charged? Because it consists of the protons and the neutrons. Now the protons are positively charged, whereas the neutrons are neutral. In this case, the nucleus cannot be positively charged, and by that, let's say that in a neutral atom, the number of protons is equal to the number of electrons. So here what I'm saying is that if the atom is said to be neutral, and in neutral it means that it carries no charge, but this doesn't imply that it doesn't contain electron or protons, but in fact the number of electrons is equal to the number of protons, and in this case the total charge cannot be zero. So in a neutral atom, yes indeed, the number of protons is equal to the number of electrons, and this is known as the atomic number Z. So let me say the atomic number, capital Z. And by that, let me construct the following table as the properties of these particles. So let me say that here we have the particle, and here we have the charge of the particle that we're discussing. So first let's discuss the electron. Now the electron is negatively charged, and indeed it's a particle, so at this level we cannot break it down, and the charge of the electron is equal to minus the elementary charge, which is equal to minus 1.6 times 10 to the power minus 19 coulombs. Now as for the proton, now the proton has a charge of equal to plus the elementary charge, Now this is the plus or the positive sign is not and it's not important at this level. This is equal to 1.6 times 10 to the power minus 19 coulombs. And as for the neutron, so let me see. Okay. Then this is denoted by the charge Q of the particle n, and this is equal to 0 multiplied by E, which is equal to 0 coulombs. And because here coulombs is multiplied by 0, so this is overall 0. And let me tabulate this data. Now here in this table we have only discussed the properties or only the charge of these particles, and the charge is a property of matter. What are other properties of matter? For example, we can talk about the mass, the size, but based on this we cannot deduce anything about other properties. So for example, we cannot say that the mass of the electron is equal to the mass of the proton is equal to the mass of the neutron. Actually, the mass of the proton is equal to the mass of the neutron. However, the proton and the neutron are much heavier than the electron. Okay, so in this table we only discussed one property of these particles, which is the charge. So here we can add another rows given by the mass, the size, but from this we cannot deduce anything related to the mass nor the size. Now let me move to section 4, discussing the deficit versus excess of electrons. Now section number 4, deficit versus excess. So let me here refer, or let me explain what is meant by deficit and by excess. By deficit, it means that we have, by deficit, it means that we have a loss or something that is missing. By excess, it means that we have an excess or too much of that thing. Now, materials may happen to be positively or negatively charged. Due to electrification. So let me say that materials in general, we expect that the material to be neutral, but it may happen sometime that this material may be positively or negatively charged, and this is due to electrification. Electrification is the process where the material gets electrified, and this process is gonna be discussed later on in the coming sections. Now, but how does this at the level of the atom happen? Let me say section 4.1. That an excess, so what is meant by excess? Excess means too much of electrons. So causes the material to be negatively charged. Now I'm gonna mention at the end something related to whether related to the electrification process. Here the thing is that now only electrons can be gained or lost. The number of protons is gonna remain the same. So now if there is an excess of electrons, so the number of electrons increases. So basically we have a material which is neutral and we have increased the number of electrons. In that case, the number of electrons will be greater than the number of protons. So the number of negatively charged particle exceeded the number of positively charged particle. For this reason, we are referring to this as an axis, and in this case, the material is gonna be negatively charged. Then we're gonna say that the total charge of the material that we're discussing is Q, which is negative, and the reason here is given by that there is an excess of electrons. Let me write it here. Then Q is negative, and this is because we have an excess of electrons, simply because the number of negatively charged particles exceeded the number of positively charged particles. And now vice versa, in section 4.2 we can say that a deficit and this is a loss of electrons causes the material to be positively charged. And in this case, Q should be positive. What does this mean? That we have a loss of electrons. So a loss of electrons, first of all, we have a material in which the number of protons is equal to the number of electrons. Now we have a deficit, which means a loss. So the number of electrons now is smaller than the number of protons, or in other way, the number of protons is greater than the number of electrons, and which causes the material to be positively charged. Then Q is positive, and the reason is given by the deficit of electrons. Now here we are just talking about the loss and the gain of electrons, and this is because due to this important note. Then let me say the important thing is that in the electrification process, so we are only talking about the level of electrification in the electrification process. This is an A, sorry for that. Only electrons are gained / lost. However, the number of protons remains unchanged. So electrons, let me refer to the atomic model. Now here electrons are only gained and lost in the atom, although so protons cannot be gained nor lost, they stay the same, the number stays the same. Although protons are positively charged, and one can ask how come they are co-joined inside the nucleus, and this is due to the strong force. So there is a strong force joining protons together. For this, one cannot expect to break down the structure of the nucleus, I mean removing protons, because it is referred to as the strong force. Whereas the electron is attached to the proton via an electric force, and basically the electric force compared to the strong force is relatively weak. So one can overcome the electric force, but regarding the strong force, it's more difficult to overcome this force, since it requires more action. Then now we are going to move to exercise 1, which is a direct application on that. Now exercise number 1. So given an electrified object A of electric charge QA, calculate in each of the following cases the number of electrons N due to charge QA and indicate whether it represents a deficit or an excess. So basically we want to determine the value of N given the value of Q. So we know that Q equals to N multiplied by E. Now we can flirt the value of N, then N is given by Q divided by E. In addition to the calculation of number of N, we need to determine whether it's a deficit or an excess. Now for number 1, Q equals to N multiplied by E, and we are flirting the value of E, then the value of N is given by the charge of the object given by QA. So here we are talking about an object A of charge QA, so the charge of this object is referred to A. Now here, let's be careful. Although the charge is given by the negative, but the negative and the positive sign only reflect the value of the deficit and the excess. In this formula, we're not gonna use it, since N gonna represents the number of electron, and this must be an integer number which is positive. So this would be 15, and this is 15 millicoulombs, and M refers to 10 to the power minus 3 times 10 to the power minus 3 divided by the elementary charge, which is given right here. And plugging this on the calculator, then the value of the number of electrons is given by 9.375 times 10 to the power 15. Now this is not enough, because we want to mention whether this is an excess or a deficit, and this can be done by looking at the sign of Q. Now Q is negative, which means that the electrons are more than the positive, so it is an excess. Then let me say that this is an excess, and the reason is given by Q is negative. So here we write the statement and we write the reason. Then let me say an excess of 9.375 times 10 to the power 15 electrons. Now in number 2, also we're gonna use this formula directly without flirting the value of N. Then N equals to QA divided by E. Now the value of Q, taking the absolute value, it's given by 16. Now mu refers to 10 to the power minus 6 divided by 1.6 times 10 to the power minus 19. Plugging this on the calculator. Now here pay attention while plugging this on the calculator, respect the form. So don't put it as 16 times 10 to the power minus 6 divided by 1.6 times 10 to the power minus 19. This would be missing a bracket here. And also it's good to place a bracket here, or you can put it in the fraction mode. Now this would give us 1 times 10 to the power 14. Now since Q is positive, which means that the protons are greater than the electrons, and we always refer to the electrons, and this is case of a deficiency. Then let me say that this is a deficit, and this comes from the fact that the charge is positive. And let me say a deficit of 1 times 10 to the power 14 electrons. Let me make some space here. And now as for number 3, the charge is given by 18 nanocoulombs, and N is given by QA divided by E. Now 18, N refers to 10 to the power minus 9 divided by the elementary charge, which is given by 1.6 times 10 to the power minus 19. And plugging this fraction on the calculator, this would be given by 1.125 times 10 to the power 11. Now in this case, if we refer to the charge, the sign of the charge is positive, and positive, it means that we have loss of electrons, which is a deficit. I'm going to say that this is the case of a deficit, since Q is positive, and let me say that we have a deficit of 1.125 times 10 to the power 11 electrons. As you can notice that in all of the cases, n is given by an integer number, but it is very large. So if we expand the zeros, we're gonna notice that it is an integer number. And finally, for number 4, n equals to qa divided by e. And here pay attention that the value of qa is given by negatives. Then we're gonna take the absolute value. P stands for pico, which is 10 to the power minus 12, divided by 1.6 times 10 to the power minus 19. Plugging this on the calculator. Now this is given by 1.5625 times 10 to the power 8. And this is a negative. A negative, it means that the number of electrons is greater than the number of protons. Then in this case, this is an excess of electrons. And the reason is given by Q is negative. And let me say we have an excess of 1.5625 times 10 to the power 8 electrons. Then that's it for me in this video, guys. In the next part, part 2, we're gonna continue solving exercises on this chapter and introduce the methods of electrification.